make it sound so grandiose. So thank you so much for being here, and thanks for your attention. We're talking about technology, and I'm going to add a few complementary ideas, hopefully, to Carlotta's presentation. And I want to tell you a story. That's the reason I'm here. It's a story of how technology is affecting our lives, and the story is called The Age of Centaurs. And the story begins with a chess match in New York City on May 11th, 1997. The whole world is watching the final game between Russian world champion Garry Kasparov and IBM's Deep Blue supercomputer. IBM had invested millions and millions of dollars in developing and marketing Deep Blue, having years and years of research and countless engineering hours to create the first globally recognized artificial intelligence computer. A year earlier, Kasparov had actually defeated a previous version of Deep Blue, so this rematch on May 11th was of considerable significance for IBM. The global media coverage was intense. The game had been called the ultimate showdown between man and machine, and we would finally figure out who reigns supreme. And I love this cover of Newsweek. It's the brain's last stand. I think it's very telling of the tone that the media was covering, of how the media was covering this story. And in fact, the narrative was very much about man versus machine, human versus computer. And this is important. And after a fierce and final match, this was the 12th game, Deep Blue made a knight sacrifice in the chess game, which wrecked Kasparov's defense and forced him to resign in less than 20 moves. So the final result was 3.5 points to IBM, 2.5 points to Kasparov. Kasparov lost the game. And many of you might have heard this story. It's 21 years old, as a matter of fact. But what hopefully few of you have heard about is what happened afterwards. I think that's where things get really interesting. This was the headline: Kasparov has deep blues after losing, a bit of a chess joke. And so imagine this: the world's foremost chess player, humiliated in front of the world, goes back to the drawing board and figures out what's next. And what he came up with is supremely interesting, in my opinion. What he did is he created a new championship, or a new modality of chess. So a year later in León in Spain, he brought in a few of his chess buddies and played the first game in what became called advanced chess, or freestyle chess, or centaur chess. And in centaur chess, as you'll notice, the human is playing with a computer against another human-computer pair. And this changes everything. So for the first time, it wasn't about the man versus the machine. It was about how can we do this game together? How can we use existing applications, softwares, databases, AIs, you name it, on the computer in order to play a whole different type of chess? And it turns out this modality is quite successful. It goes by many names. And in fact, this can also be called intelligence augmentation, IA, as a complement to AI. And it's about combining the human's capacity with the machine's abilities. Kasparov himself says that this modality, or this form of playing, is as disturbing as it is exciting, which I think is an interesting juxtaposition of qualities. And this really matters because for the last decade or so, the best chess players in the world are actually centaur players. In so-called blind matches, in freestyle chess where you don't see your opponent, the best players are no longer supercomputers or AIs. It's no longer people, grandmasters. It's actually freestyle players. It's people using computers, 1, 2, 10 computers, several applications, several people, as a matter of fact, because it is freestyle, and playing this whole new modality of chess. And in so-called blind matches, centaur players regularly outperform either type of expert. So you could make the argument that these are the best chess players in the world today. So this combination, this particular combination of intelligence is highly noteworthy in the realms of chess. But who cares about chess? If you look outside of chess, I do a little bit, but if you look outside of chess, you'll see that this pattern remains. So I'll tell you a different story. 2011, Netflix had purchased the rights of the BBC series House of Cards, and they wanted to make their own first foray into custom programming. Netflix at the time they had gotten into streaming a few years earlier, but they were still streaming other companies' productions. And in making this bet into what became known as House of Cards, obviously, in order to do this, to maximize their chances of getting this production right, what they did is they used big data. They looked at the behavior of their viewers to determine which actors to cast, which director of photography to utilize, which color palette. They did this by analyzing which tiles we hover over when we're watching or when we're choosing what to watch, these so-called actions, correlating this with IMDb data. They came up with a data-driven approach to designing the TV series. So it's no wonder, it's no surprise perhaps, that Netflix House of Cards was such a success. So this is an example of centaur thinking outside of chess. It's combining the sensibility of scriptwriters and casting directors, humans, with the kind of big data insights that is invisible to our eyes. And I want to argue that the moment you start seeing this pattern, it becomes way more common than you might think. So we actually see this emerging in other places as well. This is just an example of Netflix custom or original programming budget, as they call it, growing by about $1 billion a year. So clearly, it's working. And Netflix's VP of Original Content says it's about 70% gut and 30% data. So it's not all the data. It still relies on us to make these decisions. But again, once you see this pattern, you start noticing it everywhere. So you could argue that Waze, or Google Maps for that matter, but particularly Waze, when you're routing around traffic, is a great example of this. It's the machine making part of the decision, but it's still you driving the car, and you deciding whether you want to obey what the machine is telling you or not. Spotify's Discover Weekly feature, massive success, is another example of this. We are the ones deciding whether we like the song or not, whether we skip it, pause it, listen to it again, but it's the machine looking at all of these billions of data points that we could not see in order to come up with these 30 tracks that you might like next Monday. You could argue that health trackers are very similar, are also centaurs. Health trackers, as in they show you the kind of behavior that you can't see yourself. So it's by tracking the data that is invisible to us. Voice assistants, when we're talking to our Alexas and our Siris, we are tapping into this centaur capacity. It's our own thinking, but it's being augmented by an external device. Even the World Cup this year saw a bit of centaur thinking, the VAR, when the judges actually check the computer, the machine vision, to make sure that they made the right decision. To me, from my perspective, that's an example of centaurs in sports. Amazon's fulfillment centers, the people who work in these warehouses are told where to go and what to do by their wearable tablets that know even how tall they are, so they don't send short people to pick up things on tall shelves. So it's actually a machine manager determining how the humans should act. My favorite example is Formula One, because it's the epitome of having a highly trained human being and a highly tuned piece of machinery, but also these hundreds of people behind the scenes that you don't really notice. And all of this comes together into creating a sport that is arguably a centaur sport. It would not be possible were it only for the human or only the machine. The bicycle is another example. It doesn't augment your intelligence, but it augments your capacity for locomotion. This is an example of generative art, an Argentinian artist who creates these pieces that are generated by machine, but tweaked by his own algorithms. So it's not pure machine, it's not pure human, it's that mix that I find so fascinating. So on the human side, you might want to tap into qualities such as your creativity, your inspiration, your judgment, things that the machines don't do. Meanwhile, on the machine side, you have characteristics or qualities like scale, precision, speed, things that humans are not inherently good at doing. And it is with the centaurs that this really comes together. It's when you build centaurs that you can do that you can tap into both sides of this model and actually achieve results that are unlikely to be achievable only by one or the other. I see a lot of cameras going up. That's usually a good sign. And the notion of centaurs is the first pattern of technological transformation that I want to talk about. We're going to cover another 6. The reason why I posit this as distinct patterns is because I think oftentimes it feels that technological transformation is unforeseeable, it's unpredictable, it seems chaotic, but arguably if you actually notice that these underlying patterns, it becomes easier to sort of see into the future, to have a glimpse into what's possible, because the patterns tend to be true over time, as Carlotta has been pointing out as well. So my name is Michell Zappa. I'm a technology futurist, a self-proclaimed technology futurist, which means I try to make sense of what's happening. And I'm not the kind of futurist that tries to figure out what's next, but rather I try to sort of show pathways into what's possible and where we might end up, and hopefully help us here in the audience make slightly better decisions about what's next. I'm Swedish, 100% svensk, born in Stockholm, and as was mentioned, I've sort of been growing up all around the world, between Europe and São Paulo mostly. And the primary question that we need to, or the primary level we need to level on a definition, a working definition of technology. So it's easy to, I mean, we have certain impressions of what technology is. We tend to think about it in certain ways. Alan Kay says technology is anything that was invented after you were born. Everything we're born into becomes invisible. Danny Hill says technology is everything that doesn't quite work yet. I think these two are good definitions, and they're both true. But we tend to think about technology in terms of its artifacts, the devices and the gadgets that we use and interact with. And these are obviously technologies, but it's much more than that. Technology is everything we make. Everything we create is technological in nature, which means that writing, the harnessing of fire, the wheel, agriculture, these are all technologies. We know about some of these are more evident than others, but it's important to keep in mind that they all obey these patterns. They all move in a certain direction. And we can see this direction by looking at the visible history of certain technologies. So if you take writing and scroll back in time, the e-book and scroll back in time, you end up with papyrus, for example. If you take medical imaging, a century ago, it was unimaginable to sort of peek into the human body without sort of running the risk of killing the patient, whereas now we take it for granted. It's just obvious. Same thing with flight. I mean, these are recent inventions, relatively speaking, and they're just obvious. They're just here, and they're the normal part of how the world works. We used to hunt, now we tap, way easier. And this is a sign of sort of the direction I think we're moving in. You could say that things get faster, and things get cheaper faster, due to an observation by one of the co-founders of Intel, Gordon Moore, who had a law named after him, Moore's Law, which basically states that computers or microprocessors get twice as fast every 2 years, approximately, or twice as affordable every 2 years. This is only true in information technology. This is not true for any other industry. But because of this power, information technology tends to take over everywhere it goes. It seeps into every other industry. So this is the exponential nature of technology, that of exponential change. But the thing is, once you have exponential change, you inevitably run into unintended consequences. So I want to argue that technology is inconsequential. It doesn't really show, it's hard to show where we're going. So take something as trivial as the automobile, invented, again, it's like more popularized slightly over a century ago. It led to urbanization. It led to parking lots, massive parking lots. It led to traffic jams, actual photo. It led to deaths and accidents. So all of these are direct consequences of the faster horse. It wasn't something that Henry Ford necessarily imagined, or any other of the proponents of the automobile, but it became this inherent part of cars. The same way that the elevator led to cities like Hong Kong. You can only have dense urbanization, or you can only live over like the 4th floor if you have an elevator. The moment the elevator was invented, you didn't get the skyscraper right away. It took a few cycles. but it was directly responsible for it. Same thing with air conditioning. The founder of Singapore has stated in his autobiography that the first thing they installed in like every government building was air conditioning. So you would not have a city because otherwise you wouldn't have productivity in tropical locations. So these apparently secondary inventions lead to pretty drastic changes in our lifestyle, again, without us really noticing it. You could argue that social media leads to mind hacking, which might have affected the outcomes of certain elections. And we see this happening more and more. And of course, plastic. It speaks for itself. So we don't see the consequences of our technologies. We push them out, we use them, we buy them, we don't really think about what's next. But we can almost be certain that there will be consequences to them. Because again, if technologies are exponential, and our view of the world is largely linear, that means we tend to overestimate the short-term effects of the technologies, while we regularly underestimate the long-term effects. The tricky part that this is true even when you know it's true, so you have to keep compensating for it. This is a law, Roy Amara's law, and this tends to be true everywhere you look in technology. And the fundamental reason, again, is because of these exponentials. The fourth pattern is that of omnipresence or ubiquity, which is technology is everywhere. And the way that I want to highlight that is to argue that there is no technology industry. The problem when you think about tech companies as being part of some different aspect of society is that they don't think of themselves like that. So there's no tech industry. All companies are tech companies. Because tech companies don't think of themselves as tech companies. They think of themselves as music companies or locomotion companies or transport companies or rocket companies. It doesn't matter. They'll use any technology to achieve their goals for their shareholders mostly. And when you're a company who doesn't think of itself as a tech company, then you're just shooting yourself in the foot because you're not necessarily realizing or using all those technologies that the tech companies would be using anyway. I think we're realizing this more and more. I think we're now starting to hold some of these companies accountable for their actions. It's happening most, again, in the political sphere, but increasingly we're being more aware of this. We're being made more aware of this, and hopefully starting to make better decisions around it. The fifth characteristic is that of combinatorial evolution, which is to say all technologies are combinations of other technologies. And we can showcase this easily. We can take something like a smartphone, and we can break it down into multiple technologies that constitute the smartphone. So for example, to have a smartphone, first you need to invent the battery, you need to invent the touch screen, geolocation, communications platforms, the keyboard, et cetera, et cetera, et cetera. So the smartphone has dozens or hundreds or thousands of individual technologies within it. But this is recursive. So in order to invent geolocation, first you need to invent the satellite, the atomic clock, you need triangulation or math, you need the rocket to put the satellite in space, and so on and so forth. So every one of these technologies is actually dependent on a series of other technologies that underpin it, which creates this network of connections between every single technology. So you could argue that because of triangulation, you ended up with the smartphone. They are directly linked through a series of other technologies. And once you notice this pattern, you start understanding why certain companies act the way they do. So for example, if you're Google and you start investing in machine vision, you build out the street view technology, roll it out around the world, you invest a lot in machine learning, cloud computing, well, if you combine all of these technologies, you end up with Waymo, or the self-driving car. Because you need all of those underlying technologies to actually do the car. The car is the easy part. The underlying technologies are the hard part. And once you notice this, you understand why certain companies invest so heavily in seemingly unrelated technologies. Because, from my perspective at least, they see this as a potential future combination in order to end up somewhere that is not possible if it wasn't for this development. So every technology is connected to every other technology, and that's how you end up with future tech, effectively. This is true backwards in time and forwards in time. So you can track it to understand how we ended up where we are, but you can also use it to come up with new combinations. And that's effectively how every new technology is conceived of. It doesn't happen in a vacuum. The sixth pattern is that of inevitability. So we can't really slow down the pace of change, and it's absolutely moving in our direction. So since the chess matches, of two decades ago, there have been several other big steps in machine capabilities. So in 2011, there was the famous match of, again, IBM back in the spotlight with Watson this time, using natural language processing and winning the game of Jeopardy against some great players. This, again, was heavily featured in the news. And again, the story was very much about man versus machine, computer versus human. And this was a huge new step because compared to Jeopardy, chess is really simple. So there's always this next boundary of, especially games, because it's easy to identify a winner and a loser in games. So that's why machine learning moves towards those targets. And so we keep reaching these new milestones of computer capabilities. Likewise, 2 years ago, Google's Alphago, or DeepMind's Alphago technology famously won against Lee Sedol in Go, a game that had been claimed to be unbeatable by computers. And suddenly, there you go, they beat you. And it's another example of computers sort of encroaching on our capabilities and becoming increasingly good at doing things that supposedly only we are good at doing. So this is a form of inevitability. It keeps progressing, it keeps moving towards us. We can't really slow it down, but I think we can sort of direct how it's going to change us and how it's going to affect us. Then you have examples of computers not even needing humans anymore, or computers learning from themselves. So reinforcement learning, so it learns from its own patterns and actually becomes better without any human interaction, which is kind of scary, but also really exciting to think about. And it's a good sign of the inevitable progress of technology. So this starts raising a series of interesting questions, which I will not necessarily answer right now, but I want to sort of pose back to you, which is, which are the skills we should be optimizing for? As designers, as responsible individuals, how do we want this to unfold? If we're aware of these patterns, if we know that it's happening, how can we affect it positively? How can we make sure that it develops to our favor and not in detriment of our humanity? Because I want to argue that this will keep happening. We're not going to slow it down. We're not going to avoid it. We can move into the woods, obviously, but it's not going to solve anything for society. So it's about accepting these changes and actually adapting ourselves to them and hopefully making better decisions about what's next. This is a very rough graph trying to indicate the allocation of work. So if in the past we had, most of the work was done by humans, and in the future most of the work will be done by machines, we're in that sort of transition right now. We're moving through that. And the axes are arbitrary, but it's an indication of the direction we're moving in. So we're moving towards more automation, we're moving towards more machinery, more machine-made decisions. We're starting to ask ourselves quite frequently, what's the future of our jobs? Will we still have something to do after machines take over? And I want to argue that yes, and sort of hopefully the way out is by this creative combination between our capacities and what computers are good at. And I tried showing our replaceability as a graph. So if you think about the degree of specialization, I think people in less specialized positions are more replaceable, and especially in the high-tech intersection. So if you position it as sort of high-tech, low-tech, and high and low specialization, if that makes sense, in the high-tech, high specialization, you get the really interesting examples. That's a Netflix and the Formula One. You can't replace the driver in a Formula One car very easily. But you can replace the operator in a warehouse really easily because he's just being told, they're just being told where to go and what to do. So this is something you want to optimize for as well as an individual, as a human, as how can you optimize for high specialization? How can you be the best at what you do in order, not only as a defense against machines, but also as a general life skill. And finally, I hope that all of this change is malleable. So if it's inevitable, it's hopefully also malleable, so we can actually direct where we're going. And this takes on a lot of meanings. It means reflecting on what it means to be future-proof. It means understanding that, okay, these changes are coming towards us, this is happening, what can I do personally? What can I do for my organization? What can I do for my skills to ensure that I'm future-proof, that I'm not going to be tossed on the side of the road when something better comes along, technically speaking? It also implies a certain loss of agency that I think we have to fight against. I think technology, the technological ecosystem is, in many ways, eating up our sense of agency. It's making decisions for us. It's making us slightly less human by the day, as we allow it to, because it's making a little bit of the thinking for us, it's making a little bit of the predictions for us, it's making some of the decisions for us. We're outsourcing many parts of our brains, contact books, for example, phone numbers. As every day that goes by, we're putting a little bit more of our mind and our bodies into these machines. There's no problem with this, unless you're not aware of it. If you just do it on autopilot, then there's a problem. If you're aware of it and if you're conscious about it, and if you're actually making these decisions in an informed manner, then you're generally good. But if you're just doing it because everyone else is doing it, then you're going to end up in a tricky spot. And finally, I want to argue for inclusive futures. As Carlotta has been pointing out over and over again, it's about making the technological future as inviting and as open as possible. Currently, that's not the situation. Currently, the vast majority of technology is being developed under the purview of venture capitalists and private funds with the explicit intent of generating more capital. So it's not about necessarily improving the lives of us 7-8 billion people, but rather how can I extract more money from the planet. Again, nothing inherently bad about that, but it doesn't really go around, so we have other problems to work on. But with the intent of making the technological intelligence more inclusive, more democratic, and more open, so my company is actually building on a small initiative to making this possible. So what we realized is there's no good place to go to actually learn about technologies. Well, or rather, there's a million places to go to learn about technologies. There's not necessarily a place, a systemic place where you can read about and understand sort of how they're developing, how they're interconnected. So this is something we've been working on for a few years, launching next year. And it's basically a database of technologies. It shows you everything that's going on in all fields and all sectors and domains with the intent, and it's open, obviously, with the intent of actually getting more people on board to making these decisions, to being more informed about what's happening, to understand what's next. This is what it looks like. And Clive Thompson, author and journalist, argues that we're all playing advanced chess these days. We just haven't learned to appreciate it. So thank you.